Behind every great piece of software you use, from the simplest app to the most powerful AI, there's a great design. But what does that actually mean? And now, with AI everywhere, why is having a good blueprint more critical than ever before? Well, let's dive in and find out. Oh, we've all been there, right? You're in the middle of doing something important, totally in the zone, and then, poof, the application just dies. It's so frustrating. But it turns out that crash is usually a symptom of a much, much deeper problem, one that started long before a single line of code was ever written. And right here, this is the villain of our story, technical debt. The best way to think about it is like taking out a high-interest loan on your project. Rushing to code without a plan feels fast at first. That's the quick and dirty solution. But you end up paying for it with interest down the road. And that interest comes in the form of bugs, instability, and endless rework. It's the direct result of skipping the most important step, the design. And listen, these risks are not just minor annoyances. A poor design creates a fragile system, like a house of cards. You make one small change over here, and the whole thing comes crashing down over there. Testing becomes an absolute nightmare. And the worst part? You often don't realize how bad the quality is until it's way too late, and you've already burned through your time and budget. There has to be a better way. So, if technical debt is the big problem, what's the solution? It's actually pretty simple. It's about treating software development like any other serious engineering discipline, and that always starts with a blueprint. And that blueprint is what we call software design. It's that crucial process where you resist the urge to just dive in and start coding. Instead, you step back, you think, you plan, and you create a complete model of what you're about to build. It's where you figure out all the hard parts before you lay the first digital brick. This analogy absolutely nails it. I mean, think about it. You would never, ever try to build a house without a detailed floor plan, would you? That would be insane. You'd want to know where the walls go, how the plumbing connects, everything. Well, software is no different. The design is the floor plan for your application. So what's actually in this blueprint? Well, it's got the high-level architecture, the main pillars of the system. It defines all the interfaces, which is just a way of saying how everything talks to everything else. It breaks down all the individual components, and crucially, it maps out exactly how data is going to be structured and stored. It's the whole shebang, a complete plan of action.
Okay, so we have our blueprint. But just having a plan isn't enough, is it? It needs to be a good plan. So what are the core principles that separate a software masterpiece from a complete mess?
The cornerstone of all great design is this idea right here, functional independence. It sounds a bit technical, but the idea is simple and really powerful. Each part of your software should do one thing and do it well, without being all tangled up in everything else. And you get there by focusing on two key metrics. It all boils down to these two goals. On the one hand, you want high cohesion, where every piece of your code has one single focused job. On the other, you want low coupling, so all those pieces are independent and don't rely too much on each other. When you get that right, you can fix one part of your app without breaking 10 other things. Get it wrong, and you've got a tangled mess where one small change causes a cascade of failures. Another huge principle is the separation of concerns. Again, it sounds complex, but it's just about good organization. If your program needs to handle the user interface, do some calculations, and save to a database, you don't just mash all that code together. You create separate, distinct modules for each concern. One for the UI, one for the math, one for the database. It keeps everything clean and manageable. And let's be totally clear, these principles aren't just abstract academic rules. They exist for one critical reason: to make incredibly complex software manageable for the human beings who have to build and maintain it. They're what allow us to tackle these enormous problems without getting completely lost in the chaos. For decades, these principles have been the absolute bedrock of software engineering. But recently, a brand new character has entered the story, and it's changing the entire game. This is the question that changes everything. What happens to our carefully planned blueprints when the software itself starts to think? How in the world do you design a system that can learn, adapt, and make its own decisions? So let's be really clear about the difference here. Traditional software is deterministic. It follows a script, a set of rules that we write for it. AI-enabled software, on the other hand, is dynamic. It uses complex algorithms to learn and adapt, performing tasks that used to require a human brain, like understanding language or driving a car. The examples make it pretty obvious. Your computer's operating system is a masterpiece of traditional software engineering. But systems like GPT, Alexa, or Tesla's autopilot, they represent a fundamentally new kind of software, one that's built around intelligence itself.
So, does this new world of AI mean we just throw out the old rulebook? Do we let the machines figure it all out for themselves? Well, the answer might surprise you.
This brings us right to the central question for modern software developers. In a world full of unpredictable AI, do these old-school design rules, cohesion, coupling, separation of concerns, do they even matter anymore? The answer is an emphatic yes. In fact, they are more critical now than they have ever been. When you're building a system that can learn and act on its own, those foundational principles that ensure stability and manage complexity aren't just helpful, they are absolutely essential. The rules haven't changed, but how we apply them definitely has. Building an AI system today actually involves two distinct parallel processes. The first is what we can call the AI-enabled software cycle. This part feels pretty familiar to developers. It's about building the application around the AI. You're designing the user experience, the overall architecture, the container that the intelligence is going to plug into. The second process is the AI capability cycle. This is the new part. This is the process of actually creating the intelligence itself, training the models on massive amounts of data, iterating, fine-tuning. You do that over and over until the AI's performance is good enough to integrate into the main application. And these two cycles have to work together in perfect harmony. And that brings us to our final crucial question. In the frantic race to build the next great AI, it's really tempting to throw out the rulebook and just start experimenting. But given the stakes, can we really afford to skip the blueprint? The takeaway here is clear. Far from being obsolete, good software design has become the essential foundation for building intelligent systems. It's what allows us to manage the immense complexity of AI and create applications that are not just smart, but are also stable, maintainable, and trustworthy. Good design isn't just a good idea anymore. It truly is the blueprint for intelligence.